This is Jacob's Algebra, Chapter 11, Lesson 5. We've been working on adding and subtracting algebraic fractions up to now. In this lesson, we're going to start multiplying algebraic fractions. So we'll start off kind of doing a comparison. When you're adding fractions, let's say we have a over b, and we're going to add that to c over d. We have to get a common denominator first. So to do that, we're going to take our denominator for our second fraction and multiply that by our first fraction. Take the denominator for our first fraction and multiply that by our second fraction. And so what we end up with is AD plus BC all over BD. Now, what if we had those exact same fractions, but we were multiplying them? So what if we had A over B times C over D? Well, when you're multiplying fractions, the first thing that you always do when you're multiplying fractions is you see if there's things that you can cancel out. In this case, we have no idea what A, B, C, or D are, so we can't cancel anything out. Once you've done that, then you draw your fraction bar, you multiply everything in the numerator together. All we have is A times C, so that's AC. And then we multiply everything in the denominator together. B times D gives us BD. So you can see we get a very different answer from multiplying fractions and adding fractions. So just to show you a little bit about the simplifying part, canceling, what if we had 1/3 and we were multiplying that by 3/5? Okay, the first thing you do when you are multiplying fractions is you look to see if there's anything you can cancel out. We have a 3 in a numerator and we have a 3 in a denominator. That means we can divide the top and the bottom by 3 and replace those with 1s because 3 divided by 3 is 1. And our answer is 1/5. Now we don't have to do that. We could do 1/3 times 3/5 and say 1 times 3 is 3 and 3 times 5 is 15, and then reduce our fraction, again dividing the numerator and denominator by 3. So in the numerator we end up with 1, in the denominator we end up with 5, and so our final answer is 1/5. Remember, when we're adding fractions, let's say we had these same two fractions and we were adding them, 1/3 plus 3/5. When you are adding or subtracting fractions, the first thing you do is check your denominators. If your denominators are not the same, you have to find a common denominator. In this case, you would go and multiply the first fraction by 5/5. You would multiply your second fraction by 3/3. And then you would say, okay, 5 times 3 is our common denominator. That's 15. 5 times 1 is 5. 3 times 3 is 9. So what we end up with here is 14/15. Okay, so now let's move on to actually working some problems from this set. So we're going to start with problem number 4. Problem number 4 is just like number 8 that I assigned for homework. So once I finish going over problem number 4, you should work problem number 8 that I assigned for homework so that you know how this problem works. The problem says, express the following products as integers or fractions in simplest terms. Okay, so this means you must simplify your answer. So the first one, part A, is 2/5 times 4/3. So when you're multiplying fractions, the first thing you do is see if there's anything you can cancel. Is there anything in the numerator that can cancel with something in the denominator? In this case, there is not. So what we're going to do is just multiply our numerator. 2 times 4 is 8. Multiply our denominator. 5 times 3 is 15. There's no common factors, so 8/15 is our final answer. So now we'll jump down to part C. We have 5/7 times 5/7. Again, we check to see if there's any common factors in the numerator and denominator, and there aren't. When I say common factors in the numerator and denominator, I mean anything in the numerator that has a common factor with something in the denominator. Since there aren't any common factors, we just multiply. 5 times 5 is 25. 7 times 7 is 49. Since there are no common factors, we can't simplify any further than it already is. Okay, now let's look at part E. Part E is 9/4 times 8/3. Okay, so this time we look for common factors, and we actually do find some. 9 and 3 have a greatest common factor of 3. which means I can divide both of those by 3. I'm sorry, that didn't quite work. Which means I can divide both of those by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. 4 and 8 also have a common factor. The greatest common factor for those two numbers is 4, so I can cross those out. 4 divided by 4 is 1. 8 divided by 4 is 2. Multiply across the numerator. 3 times 2 is 6. Multiply across the denominator. 1 times 1 is 1. We simplify our answer to get 6. Now, we don't have to do it that way. We could have just said, it's not working. Okay, we could have just said, there we go, 9/4 times 8/3, and multiplied across our numerator to get 72, multiply across our denominator to get 12, and then look to see, do we have any common factors? Well, it's really obvious that 4 is a common factor here. So I can divide the top and the bottom by 4. 72 divided by 4 is, that's not 13. It's 4 goes into 7 one time with 3 left over, 32. So that means 8. 18 is what we get when we divide 72 by 4. And then 12 divided by 4 is 3. These are both multiples of 3, so I can divide again. 18 divided by 3 is 6. 3 divided by 3 is 1. So we end up with 6 as our answer. It's usually easier if you can go ahead and cancel out common factors before you do the multiplying. It means you have less of a multiplying mess to deal with, and it means that you usually, if you actually do manage to find all the common factors beforehand, then you don't have any simplifying to do at the end because you've already got it down to simplest terms. Okay, so that was number 4. It's just like number 8 that I assigned as homework, so at this point you should stop the video and work number 8, and then come back and watch the video again for number 5. Okay, so number 5. I'm sorry. I'm using a new pen and I do not know exactly how this one works. Okay, so number 5, let's try that again. It says, write each of the following as an integer or fraction in simplest terms. Again, you must put your answer in simplest terms. So we're going to jump to part E to start. We have 2x over 3 plus x over 6. Now remember, if you're adding or subtracting fractions, the first thing you have to do is check for a common denominator. We do not have a common denominator. Now there's 2 ways that we can get a common denominator. The way that always works no matter what is if you take the denominator of one fraction and multiply it by the other, take the denominator of the other fraction and multiply it by the first one, then you will end up with a common denominator. So I could multiply this first fraction by 6 over 6 and the second fraction by 3 over 3, and that would work. But what's easier is to see that 3 is a factor of 6. So if I actually just multiply this first fraction by 2 over 2, 2 times 3 is 6, and I will have a common denominator. So I don't have to multiply it by that much bigger number. So our common denominator is 6. Now we're going to multiply our numerator. 2 times 2x is going to give 4x. And then we're going to add another x because we have an x here. So what we end up with is 5x over 6. Now just to show you that we could have done this the other way, I'm going to multiply the first fraction by 6 over 6 and the second fraction by 3 over 3. We end up with a common denominator of 18. Now our first fraction, we have 6 times 2x, that's going to give us 12x. This second fraction, we have x times 3, that's going to give us 3x. So we end up with 15x over 18. But that's not simplified. We can see that 15 and 18 are both multiples of 3. So if we divide 15 by 3, we get 5. If we divide 18 by 3, we get 6. And so we end up with 5x over 6. We do get the same answer. Okay, so then we're going to do part F. Part F uses the same fractions, 2x over 3 and x over 6, but this time we're going to multiply instead of adding. So remember, when you multiply, what you look for is common factors in the numerator and denominator. And the only common factor I see is 2 and 6. So we can divide both of those by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And now we can multiply across our numerator. 1 times x is x. 3 times 3 is 9. So our answer is x over 9. Very different answer from what we got when we added the two fractions. Okay, so now we're going to jump down and do part I. I'm going to get a new page. 5I. 5I is 1 over x plus 1 plus 1 over x plus 1. Now we have a common denominator here, so that makes this a really easy problem because we just have to add our numerators. 1 plus 1 is 2, and we're done. There's nothing more to do there. So now we'll look at part J, which is those same fractions, 1 over x plus 1 times 1 over x plus 1. I did that wrong button again. Okay, so let me rewrite that. Okay. Now, we need to multiply across our numerator. 1 times 1 is 1. And then we need to multiply across our denominator. We have x plus 1. Again, it's jumping to this other pen mode, which is kind of annoying. X plus 1 times x plus 1. Okay. Now, we can, if you know how to multiply that in your head, that's fine. You can just write out the answer. If you're not sure how to do that, then please go ahead and draw your grid. If you draw your grid, you will always get everything multiplied out because you will know if there's an empty spot in your grid. X plus 1, x plus 1, x times x is x squared, 1 times x is x, 1 times x is x, and 1 times 1 is 1. So what we're going to have is 1 over x plus 1 times x plus 1 is x squared plus x plus x is 2x plus our 1 here. And that's our final answer for number 5, part J. So we're going to work just one more pair. Let's look at number 5, part K and part L. So part K, we have, where did it go? 2 over x squared plus, it messed that up again. 2 over x squared plus 3 over x cubed. Now remember, when you're adding or subtracting, the first thing you do is check for a common denominator. We do not have a common denominator. But if you notice, we have an x squared for one denominator and an x cubed for the other. We can make our first fraction have the same denominator by multiplying it by x over x, because x times x squared will give us x cubed. So that's what we're going to do. We have a common denominator of x cubed. 2 times x is 2x plus 3. And that's our answer, 2x plus 3 over x cubed. Part L is taking those same two fractions, 2 over x squared, and then multiplying them instead of adding them. 2 over x squared times 3 over x cubed. Do we have any common factors in the numerator that are in the denominator? No. So 2 times 3 is 6. X squared times x cubed is x to the 5th, because remember, when you multiply numbers with exponents, you add the exponents. Those exponent rules are never going away. So make sure you do have that bookmark with the exponents rules written on them. That will really help you. So this was number 5, which is just like number 9 that I assigned as homework. Remember, your answer must be expressed in simplest form. You have to reduce your answer once you've got it. So stop the video now, work through number 9, and when you're done with that, come back and watch the video for number 6. I am not going to be able to finish number 6 on this next video, so you will need to finish number 6 on the part 2 video. But do come back to this one because I will at least start number 6. Okay, so number 6 says find the following products expressing your answers in simplest terms. So we're only going to be doing products here. And we're going to start with A, 7 over 3 times 9 over x. We look for common terms. We can see 9 and 3 both have a common term of 3. And so we end up 7 times 3 is 21, 1 times x is x, and 21 over x is our answer here. Now, when I come back in the part 2 video, I will work more parts from problem number 6. So start the part 2 video and watch that for the rest of number 6. And after we finish working through number 6, then you can do number 10 that I assigned for homework.